manufacturing, technology, hot topics, and a little bit of tomfoolery. This is the MTD Podcast.
Hello and welcome to today's podcast. I'm joined by two very familiar guests, Mr. Paul Jones and Giovanni Albanese,
Good to see you again, Joe. Good to see you again.
Welcome.
Yeah.
And two guests you may or may not know, Clinton and Chris from Autodesk. Gents, welcome.
Thanks, Good afternoon.
Good afternoon.
Good afternoon. So we reached out on social media about today's show and the topics, and one thing that came to the top was future and current trends in CAM. So who wants to start?
Well, that's a big topic. So we've spoken before, Gio. We've discussed it a couple of times. One of the things that Autodesk has been promoting for quite a while is this convergence of design and manufacturing. So for years and years, parts have generally been designed by one team. They reach a point where they're ready for manufacture. They're literally thrown into a different department and somebody picks that up and starts to manufacture it. But at that point in time, the manufacturing engineer says, I can't make this part, it's rubbish. It doesn't have the necessary draft on it or whatever. And so you get this toing and froing between the design and manufacturing team. And so for a while, we've been promoting the fact that we want to change that mindset so that design and manufacturing get combined together. And so the method that you're going to use to manufacture the part massively influences the design that you create. And that sort of leads nicely onto the technology that we've had for a while called generative design. And in the past, we've been able to talk about the fact that, let's say you've got a component that needs to be really lightweight, maybe it's a motorsport component, an aerospace part. You can generatively design the component so that you're going to lightweight the component, maybe use 3D printing and use that as a method of manufacture. About 6 months ago, we enhanced that technology so that the generative design can create a component that's more appropriate for 5-axis milling. What's really exciting is literally just the last week, we've upgraded that technology to allow you to say, well, actually, we need a part that's suitable for 2D or 2.5D machining.
Because that's a bigger market, isn't it?
It's absolutely humongous. I mean, Chris will know this for sure. You look how many of our customers actually own a 3D printing machine. Probably not that many. More will own a 5-axis machine, but it's the minority of our users. But every single one of our manufacturing customers will have a 3-axis machine tool. All of a sudden, we just unlocked access to generative design technology for those machines.
And the biggest advantage, is it down to weight?
That's one of the reasons. Yeah, generative design aspires to create a component that is optimized for weight, but also to create a component that's designed to serve a purpose. I think if we, as all design engineers, created a component to serve a job, we'd probably all over-engineer it. Whereas the nice thing about generative design is it's using cloud-based computing, infinite power of the cloud, to generate a whole load of different design variables that have got the right strength properties. And then you just choose the one that looks the nicest based on various different levers. Is it a 2D machining job, 5-axis machining, and so on?
It sounds like a complicated bit of software. Has it taken a long time to develop?
We've been developing it for a great number of years. From an end user's perspective, the point is it's running on the cloud. So you literally say, I've got a component that needs to be fixed in these positions. I'd like to make it using CNC machining. 2D, maybe 5-axis, not sure at this moment in time. Let the cloud, artificial intelligence, create the designs. Leave it for 10 minutes. You've got thousands of PCs effectively in the cloud there that can create the designs. You don't have to sit there and calculate a few.
And is that the kind of waiting time? You're talking a matter of minutes to come back with the answer?
It varies obviously depending on the component that's being designed, but it can be incredibly quick, because of the infinite power of the cloud.
I've been experimenting with it. For very simple components, you do get 20, 30 results back within 5 to 10 minutes. You start throwing more materials at it and more constraints, i.e. I want X amount of force in this direction, I want X amount of force in that direction, and I want so much twist in this direction. Obviously, time can go up, and then we need to maybe a few hours. But once that data's up to the cloud and computing, you can then carry on working, do whatever it is you do, and then you get an email ping back to say, your data's finished. So then you click it, you get all your results back, you choose the one that best suits your manufacturing facilities. Away you go.
So effectively, Chris, are you saying that you're putting in or adding this information into this software, your machines, the technology that you've got available to you as an organisation, and this is just going to feed you with the very best design that is possible for the machine that you've got?
I mean, it always sticks in my mind that from my days of designing forgings in the forging industry many, many moons ago, and some guy says to me that basically a forging is just holding holes in space. What goes on between it really is irrelevant as long as it misses, where it fits. And that's pretty much like what generative design does. It looks at the let's say, for example, with machine, we're producing a simple bracket. It's got 2 or 3 mounting holes. There's loads on those holes. So you specify that these are the holes where I'm mounting. This is the load on this bracket. I've got access to a 3-axis milling machine, and I've got access to a 5-axis machine. That's it. This is my material. These are the loads I need. Go away and come up with something. And you actually only upload the hole features. You don't actually upload the model. So you tell it what are obstacles and what you want to preserve. So in this case, we want to preserve the hole features, and obstacles could be something that's in the way between those hole features. So off it goes, and then it sends back this, what looks like a really kind of organic shape, but it's still meeting design constraints and design properties with the loads that you've specified in those mounting positions.
And there's a payoff, presumably, between machining time, and the advantage you get through generative design.
Absolutely. And again, it's using less material, and it's a lot lighter, and it's not over-engineered, and it's meeting design constraints.
When you say organic looking parts, you're referring to maybe 3D milling, aren't you?
Yes.
So I would imagine that, albeit you're getting better strength from it because you're rounding off corners instead of having sharp edges, but surely scanning the part is going to take longer than machining that part as we did before.
Yeah, but we're not talking very high volume parts here. We're talking parts at the moment that are for motorsport, for aerospace, for prototypes, for small batch, small sports car companies. For BAC Mono is the classic example in case. Their cars are built to order. They're not making hundreds of thousands of these parts. So time is not the target
that
here.
is changing. For a while, I think you've been absolutely correct. The technology is at the bleeding edge. Is expensive. In the early days, it was expensive, and it wasn't particularly rapid. In terms of using 3D printing, it's not a rapid process. Likewise, 5-axis machining. You make a 5-axis machine part, it can be slower than to make a 2D machine part because obviously they're more organic and doubly curved in shape. So you're right, Chris, there's those high-end aerospace customers that are really trying to push the boundaries in terms of weight savings, etc. But we've got a customer, GM Motors in the US, that actually decided to investigate using generative design to redesign a seatbelt bracket from the rear seats. So this is mainstream mass-produced componentry. And the parts were originally designed using pressed sheet. I think it was something like 8 components that were fabricated, welded together. That was your finished assembly. So you've got 8 components, you've got the supply chains behind those 8 components. Quite a complex solution to get that one part made. What GM did was work with Autodesk to come up with a generatively designed alternative that was lighter, although that wasn't the reason for them doing it, but it was a single component. So instead of having 8 supply chains to manage, and obviously you've got ebbs and flows in that supply chain, you've now got a single component that can be produced. Yes, it takes a little bit longer than a pressed sheet component, but the end result is more appropriate for the sort of design that they wanted to end up with one single component, one single supply chain. It radically changes the way they go about sourcing those components. So it is becoming more mainstream, but it's still got a ways to go.
It's that link, isn't it, between the design and the manufacture, really? Because I'm thinking general machine shops, you said it opens up to a lot of new potential users, but often machine shops, they get a drawing, they're told what to make, and they just go and make it, don't they? So this isn't really necessarily applicable to that. It's more the case of when someone's tasked with making a new component from scratch, or re-engineering, design for manufacture.
It potentially offers a huge saving, be it weight, material usage, manufacturing cycle times, whatever it is. It offers an advantage. But you're absolutely right. There are still the vast majority of customers that are, for our customers, that are manufacturers of components for other OEMs, and they're given a part, make that. And obviously, we're continuing to serve their needs with improvements to the core products that we've been providing for years.
So effectively, Clinton, what you're saying is simplifying the design process, but not only simplifying the design process, you're bringing the design and your manufacturing together. So you're kind of making it foolproof. So, for example, from my own experience, I've received drawings where components have been totally over-engineered. You're trying to eradicate that and create a process of it being one and not 2 segregated processes.
Well, if you think of it like this, you have a design engineer who he sits in front of an inventor, he sits there, he designs his part, that's my part. I think that's going to work. He puts it into finite element analysis. It's way over-engineered. Takes it back into Inventor, changes some, takes it back into a finite element analysis. Still a bit over-engineered, takes it back. And it's this to and froing until he hits where he needs to be. Generative design doesn't look like that. You know, you'd give it the design constraints you need, and it's right first time. Because we've proved it. We've designed parts in generative design that have to take X loads in X place. We've put them in finite element analysis when the generatively design has come back, and it's on the nail first time.
So generative design, I've seen it at a number of places where you guys have exhibited. Is there anything else apart from a generative design? You know, what's next after that?
Well, that's a great question. I mean, obviously we continue to develop the core products that we've developed way back to the days of Delcam. You know, Chris and I are from the Delcam days, so the likes of PowerMill, PowerShape, PowerInspect, FeatureCam, they continue to evolve. You know, we've just released, as we've discussed on previous MTD Swarf and Chips recordings, we've continued to put new functionality into that product. So we recently upgraded the high efficiency machining code inside the PowerMill product with a new Vortex from stock option. And we've been using that on a number of demonstration pieces recently. And for something that's relatively straightforward and relatively simple, it adds huge value to our end customers. Cycle times come down, tool utilization goes up, you know, the costs of manufacturing part reduce as well. So you've got these high-level generative design, real disruptive technologies that, you know, some of our customers not actually be ready to embrace yet. They don't want to go down that road just yet, but they know that there's that pathway. If their business evolves and they want to, they can go down that road. But there's still a lot of our customers that are down, you know, on the machine shops, cutting 5-axis, 3-axis parts, and we keep giving that improved technology to allow them to do that.
Well, one thing I'd like to ask as well and bring to the table is your subscription model. Mm-hmm. We hear a lot about this. I'd be interested to know the commercials behind it and how customers see that as an advantage, because it is a point of conversation. I mean, that's changed, hasn't it, in recent years?
Yeah. So we're not the only software vendor to go down the road of subscription, and we're not the only engineering software provider to do that. You think most of us, I subscribe to Netflix, I subscribe to, my wife actually signed me up to Amazon Prime recently.
You should see what he subscribes to.
I don't want to know.
That's our weekend show.
Yeah.
So, you know, subscription...
I've seen that.
Subscription is mainstream. In the bigger, wider world, it is still mainstream. But you're right, that there's still some of our customers that find that a little bit alien. They've become so used to owning the software. In reality, they've purchased a license to use the software in perpetuity, if I've said the word right. They don't own the software, but they own the rights to use it forever. So a subscription is a change. Now let's look at the fundamental difference. You can subscribe to an Autodesk product. It's generally a hell of a lot cheaper than it would be to buy a license outright. And to be fair, it's a hell of a lot cheaper than a lot of our competition right now if you wanted equivalent capabilities. So there's an instant win in terms of price point. What does that mean? Well, if you're having to pay a minimal amount of money to subscribe to a piece of software, that gives you more capital and operating expenses that you can use to invest in new fixtures, new tooling, new machines. So you get the benefits of using the latest software technology, and you've got capital, cash, free, that you can use to invest in extra technology. So the return on the investment that you get is a lot shorter. Because if you imagine if you had to buy a license of software and it was £40,000, £50,000, that's £30,000 potentially that you've now not got in your back pocket that you can invest in machinery.
And I guess you have to spend that money, don't you? Whereas maybe I'm expanding, and then maybe there's some, you know, I have a downturn after Brexit.
Well, you could argue if
I have to lose engineers, presumably I just cancel my subscription, and you know that expense is saved.
But then you haven't got your CAM. So you could argue if you paid for it.
No, but I've only got rid of two of my programmers. I've still got two. I'm just quiet.
Yeah. The point is there's some flexibility.
Yeah.
If I'm really honest, the real kicker here is that the onus is on Autodesk to continue to deliver to our customers value. So they want to subscribe. If we don't, then why would a customer move from the old method of licensing to the new? And so we continue to put more and more value into the subscriptions for our products to make them so tempting and to give our customers a competitive edge. For example, we've talked already today about Fusion's generative design technology. I hadn't mentioned Fusion until just now. So the generative design capabilities is delivered to our customers through Fusion 360. Now, as of the 30th of November onwards, next few days after the 30th of November, all subscribers to the former Delcam products, the PowerMills, the PowerShapes, FeatureCam, PowerInspect, we're now giving them access to Fusion 360 at no extra cost. So they'll be able to access that Fusion generative design technology. There may be some consumption-based costs. If you do lots of simulations of generative designs, there might be some cloud-based costs there. But you get access to all of that Fusion technology to sort of enhance the subscriptions to your PowerMill.
And do you think often with ways and methods that are successful, others tend to follow? Do you think that might happen in the market with the subscription model?
Yeah.
I can pretty much guarantee that.
Yeah. So I literally on social media last night, as I was sat there rather sadly scrolling through MTDCNC's latest Dwarf and Chip video, I actually saw something from one of our competitors, a very well-known 2D 3 to 5 axis CAM software, I won't name drop them, offering a subscription option with discussions about the extra value that can be layered on top of that. It's not just a purchase of software, it's some flexibility, all the things we talked
everything else comes on. And we talk about this a lot, and in the early days when we were acquired, it was a very hot topic internally as well. And it all comes back to the car analogy. No one buys a car now. Everyone leases a car. And it's the same with software. Everyone subscribes to software. You're subscribing to a car, aren't you? It's fully maintained, it's fully serviced, and it's exactly the same with the subscription model with software. The support is there, the maintenance is there. It's a single cost.
As a company, we Adobe. We
subscribe to Adobe. Yeah,
thank you. Subscribe to Adobe, and I wouldn't like to think what that will cost to purchase all that outright. I know
all the licenses that we have.
Yeah, exactly.
I subscribe to Adobe at home for home
tens of
use, and
thousands.
it's £10 or £12 a month or something like that.
What do you subscribe to, Gio? Come on, I feel like we're missing out.
I subscribe to Sky, and I pay for my car monthly. But I think from a flexibility perspective, I think it's key to subscribe because your technology is continuously evolving. Every week, every month.
It's like anything else. You're never going to please every single person, are you? There's going to be some that don't like it, and that's fine. You can't please everyone. Even our CEO, Andrew Agnos, has said exactly this. It's the move to the subscription model. It's a political hot potato. You're not going to please everyone. Someone is not going to be happy. They're going to jump ship and go, that's fine. You can't please.
And anything new,
everyone.
People are always going to try and pick fault.
But somebody had to be the first in the sector, didn't they?
Yeah.
They had to be the
Absolutely.
first. But everyone will follow for sure, because that's the life we live in.
And you know what? It's and Clinton will back me up. I'm the world's biggest cynic sometimes. And
He's right, Grumpy Watson.
And I was very,
and
it's taken us all by surprise internally. We've gone, you know what? This has actually worked.
It's not an obstacle.
Our
customers initially they needed some educating, and it's immediately a shock to the system. Engineers tend not to like change. We have been quite set in our ways for a number of years. So things like embracing generative design, that takes work on our part to really promote the value of it and encourage customers. This isn't just marketing fluff. This is something that really can change your business. Subscription's the same thing. I emphasised the point I made before. If our customers don't see value in the subscription, we have failed. So our job is to make the subscription so appealing that our customers can't resist going that way.
But surely it's nothing to do with the subscription. The subscription is just part of people buying into Autodesk because they're getting the latest technology all the time. It's enhancing their business with you.
Yep.
They're growing with you.
Yep.
Because if you bought a package and a fixed package, they could be years behind the technology that is evolving. So surely that is part of the business plan?
You're absolutely right. And we've had situations where customers have presented to us the equivalent price over 5 years for a subscription to our products versus the equivalent price for 5 years of maintenance for a competitive product. And obviously that first year we are a hell of a lot cheaper because we're a subscription, and that's a fixed price. A fixed price which makes it easier for you to budget, by the way, for those 5 years. But when you look over the cost of the 5 years, the difference is actually quite small.
What about overall business at the moment? We're certainly seeing in manufacturing CAM suppliers, other CAM suppliers that we talk to, having exceptional years year on year. You guys the same?
Very much so, yeah. I'm not privy to the sales figures, and I think we're nearing the end of a financial quarter. So even if I had them, I'd have to shoot you once I'd announced them and destroy the tape. But to tape, old man.
Tape granddad. It's on subscription.
Yeah, but I am 28, remember. So no, business is booming for us, absolutely. Autodesk
New user market as well, because that's obviously
Say again,
the
sorry?
new user market, new users into CAM, you're getting into the new companies.
Yep, absolutely. I mean, we focus on keeping our existing customers happy, obviously.
Yeah.
I go back to the subscription point. We want our customers to enjoy working with Autodesk, get value from the products that we deliver and the services that come with it. But obviously, yes, we are growing our business elsewhere.
Because I feel and obviously it's, I'm not just saying it's down to MTD, but some of the education that we've been doing with yourselves and others, I feel has certainly, when we visit engineers, they're buying into it. They're beginning to see that.
Like excellent to say, it's early days. And the first 18 months or two, maybe even 3 years of the subscription model is a bit of a shock to the system. But now it's maturing, and people are moving over from maintenance to subscription because of the financial benefits to existing customers. It's settled down, and it's now in that.
But generally, the old-fashioned engineer who would never have even considered a CAD/CAM solution, they now are, aren't they?
Well, it's become accessible now, hasn't it? I mean, the cost of 5-axis machines has come down massively over the last 5 to 10 years as technology's moved on along with anything else. It's now made 5-axis machining and high-tech and high-value machining more accessible now to small companies,
and at
2
the same
and 3 and
time,
4-man bands, because they can buy in for a much, much lower cost now.
At the same time, the software that drives those machines, it's really interesting that you look at a customer's investment, they'll consider the cost of that machine too. It's a big cost. But ultimately, without some decent engineering software to drive it, it's just a paperweight.
Geo used to say the same about work holding. That's why you can
Exactly.
So it's all part of the big.
Yeah, it's the link, isn't it? You need to. You're only as strong as your weakest link, and you need to have all of the complete process to be able to get the best
100%.
results.
So for us, the ability to take PowerMill, the software that Chris and I love dearly, the fact that we enhance that, so you've got easier to use tools for 5-axis programming. People are still a little bit put off by 5-axis. What if I make a mistake? I could destroy the machine. Machines are getting smarter so that they can detect and avoid collisions, even if you've MDI driven the machine by manual jog boxing. Likewise, our software's got the ability to avoid collisions, so you don't have that fear factor that when you press the green button, you might come back in 10 minutes and find that there's a smouldering wreck of a fixture on the table.
I could show you a broken cutter out there that I managed to do this week. Yeah, I wasn't concentrating.
No, well, mistakes do happen.
I've been very, very informative, gents. Really enjoyed it.
Yeah,
Oh, wonderful. Thank you.
Appreciate you coming on the show as always.
Yeah,
Good stuff.
Our pleasure. Thanks for the chance.
Thank you.
brilliant. Thank you.
Cool.